Hello dear friends, myself Sunil Sonigra. Today we are going to discuss about the multi-view representation problems, typical problems with the basic concepts, some of the problems from industries, and the importance of the multi-view representation and the very basic of the orthographic representation of the drawings. First, drawings. What do you mean by drawing? Drawing is a graphical representation. The fact about if compared with the verbal or written description, drawings offer far better idea about the shape, size and appearance of any object or situation or location, that too in quite a less time. Hence, it has become the best media of communication not only in engineering but also in almost all the fields. Drawing is widely used. Drawings, types of drawings are there, that is natural drawing, drawings of landscape, scenery etc., geographical drawings, that is maps etc., botanical drawings, plants, flowers etc., then zoological drawings, creatures, animals etc., portraits, human faces, expressions, and engineering drawing, that is projections. Now we dealt with the engineering drawing, which is subdivided into two categories, that is building related drawings and machine component drawings. In both the cases, the drawings may be orthographic projection and isometric projection. In orthographic projection, three views are there, mainly which is used, that is front view, top view and side view, and this terminology is used by mechanical engineering students, and plan and elevation are the terminologies used by civil engineering terms. So working drawings in 2D type belongs to orthographic projections. And the second is isometric projection or isometric drawing, which term is used by mechanical engineering students, and the perspective drawing, which is used by civil engineering students, and actual object drawing in 3D is covered in perspective or isometric. Both are alike. Orthographic projections. It is a technical drawing in which different views of an object are projected on a different plane surfaces, different reference planes, observing perpendicular to respective reference plane, and different reference plane are three different reference planes are there, that is horizontal plane, vertical plane which is called as VP, and side or profile plane, and different views are front view, top view and side view, and these three views are categorized as front view as elevation for civil students, top view as a plan for building drawings, and side view is as it is side view. Front view is a view projected on vertical plane, top view is a view projected on horizontal plane, and side view is a view which is projected on profile plane. Important terms of orthographic projections are planes, pattern of planes and pattern of views, methods of drawing orthographic projections. So these are the three orthographic projections. Planes. Now we discussed about plane, principal plane, that is horizontal plane, and vertical plane. So this is vertical plane and this is horizontal plane, HP and VP. Then auxiliary planes. Auxiliary plane means AVP or auxiliary inclined plane or profile plane. If it is given that AVP means auxiliary vertical plane, it means that plane is somewhere here, like this, shown by this green colored. This plane makes some angle with vertical plane, hence it is called as auxiliary vertical plane. AVP, parallel to HP and parallel to VP, or make some angle with vertical plane. Then AIP, auxiliary inclined plane. It means that the plane which makes some angle with horizontal plane and perpendicular to vertical plane, as shown over here. This kind of plane is called as auxiliary inclined plane or AIP. and this is the angle made by AIP with horizontal plane. And profile plane means the plane which makes an angle of 90 degree with HP and VP both, like this. This plane is called as profile plane. So this is the main difference between AVP, AIP and PP. Actual patterns of planes and views of orthographic projections drawn in first angle projections are shown over here. HP and VP, this is profile plane. This is a pictorial setup of all three planes, that is VP, HP and PP. Arrow direction is a normal way of observing the object from here, but in this direction only VP and a view on it can be seen. The other planes and views on those cannot be seen, like this. Now procedure to solve above problem. How to solve this problem? So for that, to make those planes also visible from the arrow direction, like this, HP is rotated 90 degree downward. We have to rotate this angle, this plane at an angle of 90 degree. B, PP, that is this one, 90 degree in right side direction, like this. Rotate this in right side at an angle of 90 degree as shown over here. This way both planes are brought in the same plane containing VP. So all these three planes are in the same plane. Click to view animation over here. Now next, here PP is rotated in this way. HP is rotated downward 90 degree and brought in the plane of VP. So by rotating this way, all these three planes can be drawn in the single view, like this: front view, left hand side view, and this is top view. So this is in first angle projection method. Front view is drawn above, top view is drawn below front view, and left hand side view is drawn to the right side of its front view, which is shown over here. And this XY represents the intersection of two planes HP and VP. PP is rotated in the right side 90 degree and brought in the plane VP. So first step is this, second step is shown over here. So finally this is the drawing. Three views, vertical, this is vertical plane, this is PP profile plane, and this is horizontal plane. XY line, front view, this is top view, and this is the left hand side view of given object. Now methods of drawing orthographic projections. How to draw orthographic projection of the drawing? So first is the first angle projection method. Here views are drawn by placing the object in first quadrant, front view above XY, top view below XY. And in third angle projection method, here the views are drawn by placing object in third quadrant. So top view above XY line and front view below XY line. Symbolic representation of both methods with an object standing on HP or ground on its base. It is like this. This is a symbolic representation for first angle projection method, and this is the symbol to represent the third angle projection method for the drawing. Only this shape differs. This is front view and this is top view. In this case this is front view and this is top view. So this is for symbol of third angle projection method if we rotate horizontally, and this is the symbol of first angle projection method if we rotate horizontally. HP term is used in first angle projection method, that is horizontal plane, and for the same ground term is used in third angle projection method. In some cases the people write the ground level. So in those cases ground means it's a horizontal plane, and in some cases people write HP when they use first angle projection method. So that is HP. Now this is the first angle projection method. In this method the object is assumed to be situated in a first quadrant, means above HP and in front of VP, and objects is in between observer and plane, then it is first angle projection method as shown over here. Actual pattern of planes and views in first angle method of projection is shown over here: front view, top view and left hand side view. Suppose this is an object, could be seen for front view. from here, this is shown by blue colored, for top view shown by green colored, and for side view shown by this yellow colored. These are the three views, and if you look from the front side, this blue colored portion will appear as shown over here as a rectangle. So here we are placing this drawing in vertical plane. So in front view, this plane is VP, right? Front view is drawn in VP. Similarly, if you look from the top view is projected on this green colored portion, that is horizontal plane. So if you draw, whenever we are drawing front view or top view, it is drawn on horizontal plane. Similarly, it's a side view as shown by yellow colored, that is shown by PP. As mentioned over here, a rectangle. PP means profile plane. So these are the three views of given object. So PP is side view is drawn over PP, top view is drawn on HP, and front view is drawn on vertical plane. Now about third angle projection method. In this method, the object is assumed to be situated in third quadrant, below horizontal plane, behind vertical plane, planes being transparent, and in between observer and object. We assume that the plane is between observer and object in third angle projection method. The actual pattern of planes and views of third angle projection method is shown over here. Suppose this is an object, this is a ground as shown over here, and this is a plane on which we are putting our drawings. So this is horizontal plane. So plane is in between the viewer and the object. Viewer is here, we are looking from here. So if you look from here, this plane or this object will appear as a plane as shown over here, as a rectangle shown by green colored on HP. Right? Similarly, for side view or for front view, if you look from the front, this plane is in between the observer and object. So this is vertical plane, we are looking from here, and it will visible like this. So here we assume that this plane is transparent and this is the object as shown by blue colored, that is front view. So front view is drawn in vertical plane. And about profile plane, if you look from this side, say from side view, in this case this is a left hand side view. If you look from here, it would appear like rectangle as shown over here. So this rectangle is the side view. So these are the three views in third angle projection method. Now about orthographic projections and machine elements. Object is observed in three directions. The directions should be normal to the respective planes, and now project three different views on those planes. These views are front view, top view, and side view. Front view is a view projected in vertical plane, top view is a view projected in HP, and side view is a view which is projected on profile plane. First, study the concept of first angle projection method, and then study next further cases in this given problem, which are shown over here. This we have discussed. Object, three views, first angle and third angle. This is ground, three views. Now think about this object. So this is the object. Pictorial presentation is given here. Draw three views of this object by first angle projection method. So this is the for front view, this is an arrow. If you look from here, this will appear as shown over here. This is shown by this dark pink color. So in front view, this would be the rectangle. This step would be visible like this. And this is the front view of this case. Now about top view. If you look from the top, this green colored portion or green colored plane will visible, right? So put arrows from there, look from infinite distance so that no any hidden edges would be visible, and this L shape would appear as shown over here, and these two green rectangles would visible as shown over here. So this is the top view of this object. And about its side view, if you look from this side, this L shape would appear. Draw projection line from here. Or if you take photograph from this side, it would appear as shown over here. L shape and 2 rectangles. So these are the 3 views of this given object, that is called as side view, and this is orthographic projections. It could be drawn like this. First draw XY line, then draw its front view as we have drawn over here like this. It's a front view. Similarly, by taking projection from the front view, draw projections from all these corners and draw its top view, and this is the top view of this object, and draw appropriate lines, whether they are full line or dotted line, and after that draw its side view, taking projections from this side like this. So if you look from the side, this is the side view, and put appropriate types of lines in this side view, and this is a left hand side view of this object, as we are looking from left side of this object. Now second problem, this is the case, this problem is there. Now how to draw its various views? So for that, if you look from the front side, if you look from here, this blue colored portion would visible to us, which is to be drawn like this. If we take projection from here, or if we draw a lines from infinite distance from these corners, it would appear as shown over here. This rectangle, and this rectangle, right? Now about its projection, so this is the front view. Now about its top view, if you look from the top, these green planes would be visible. So draw a projection lines, or take photograph from infinite distance of this object from this top side. If we take photograph from this top side, it would be visible like this. This is a rectangle, these edges, and this dotted line. Here this corner or this edge is not visible in the top view, hence it is to be represented by this dotted line in this view. This is the top view of this object. Similarly for side view, yes, of course, assume or imagine what should be its side view. As shown over here, this yellow colored portion is the side view of this object. So for that, project from all these corners to this plane. So this yellow colored shape would appear as shown over here, and that is the side view of this